In this video, we'll focus on an intervention we could see during our lifetimes: stratospheric aerosol injection. A clunky term that means spraying stuff very high up in the atmosphere to keep the sun away. Keeping the sun away. CO2 doesn't heat up the planet on its own. Almost all of the energy on Earth comes from the sun in the form of electromagnetic radiation. About 71% of this energy is absorbed by the Earth's surface and atmosphere. This absorbed energy is emitted again as infrared radiation, and CO2 is able to trap this infrared radiation and keep it in the atmosphere for a while. You can compare this effect with snuggling under a blanket in the morning. Even in a really cold room, your body emits infrared radiation, and the air between your body and the blanket traps it and creates a warm and comfy feeling. So one way to cool down the planet would be to prevent energy from getting trapped under our planet blanket, which is already happening naturally. About 29% of the solar radiation hitting Earth is reflected back to space by bright surfaces like ice, deserts, snow, or clouds. More reflection, less energy, less warming. We can look at nature for inspiration. Specifically, the 1991 Mount Pinatubo eruption, the second largest volcanic eruption of the 20th century. Aside from massive devastation and almost 900 dead, scientists noted its strong impact on the global climate. The explosion ejected millions of tons of particles and gas as high as the stratosphere, which hung around there for a while. The stuff that's interesting for geoengineering is sulfur dioxide, a nasty-smelling and invisible gas. High in the atmosphere, it produced a haze of sulfuric acid droplets that mixed with water and created giant veils. These veils reduced the sunlight reaching Earth's surface by roughly 1%. Global average temperatures dropped by 0.5 degrees Celsius. It took 3 years until this cooling effect had stopped. Humans could imitate this process by injecting sulfur particles directly into the stratosphere. According to some scientists, this might be surprisingly easy to do, and we don't even need a lot of new technology for it. According to one study, it also might be pretty cheap compared with the costs of rapid climate change. A small fleet of specialized aircraft could ascend once a year and distribute aerosols along the equator from where they would be spread around the world. Projections assume that injecting between 5 and 8 megatons of material per year would reflect enough sunlight to slow down or even stop global warming, giving us precious time to transition away from fossil fuels. Unfortunately, there might be a few unhappy side effects. There are a number of potential issues with aerosol injections. Rainfall patterns could change, which could negatively affect agriculture and cause famine. Billions of people could be affected in the worst case. Also, after the 1991 Mount Pinatubo eruption, the acid water veils not only cooled down the surface, they also heated up the stratosphere. As it turns out, acid is bad for the ozone layer, and the ozone hole over Antarctica was the largest it has ever been. Injecting sulfur particles over decades could have a similar effect. Scientists have already suggested using a combination of different minerals that might have much less harmful effects on the ozone layer, but more research and experiments need to be done to make sure this could work. But even if we don't damage the ozone layer, there are other risks. Politicians and industry might use the cooling effect as an excuse to delay the switch to a carbon-neutral economy. Even if geoengineering slows down global warming, humanity is still adding extra CO2 to the atmosphere. More CO2 in the air means that the oceans absorb more CO2, which makes them more acidic. This is already beginning to be deadly to huge ecosystems like coral reefs, and the longer this continues, the more severe the effects will be. But it gets worse. Once we start pumping particles into the atmosphere on a massive scale, we might be forced to do so for a long time, or we could risk a termination shock. What that means is that if humanity continues to enrich the atmosphere with CO2, but at the same time prevents the planet from heating up by blocking solar radiation, we're sitting on a time bomb. Once we stop geoengineering, the natural cycle will take over again and Earth would heat up. But after a few decades of keeping the planet artificially cold while still releasing massive amounts of CO2, it would heat up much, much quicker. An increase in temperature that would take 50 years today could happen in just 10 years. Such a temperature shock in such a short time would disrupt every major system on Earth so much that it would be impossible to adapt in time. The worst-case scenario could be dramatic famines and the rapid destruction of ecosystems. Humanity might survive, but the survivors would inhabit an unfamiliar and hostile world.